So in this lab we do chromatography, and it's a separation technique, and it's one of the most widely used analytical tools for separating a mixture and identifying its component parts. On the molecular level, for example, if you had a non-polar solvent and you placed your TLC plate in it, the more polar solvents would move higher up on the piece of paper. So the polar solvents would interact more with the mobile phase. So that means they would move rapidly within the mobile phase, and if they didn't move at all, that means they interacted more with the stationary phase, and either they didn't move at all or they moved very slowly.
An RF value is the retention factor, and in this ratio between the distance traveled by the component, which is the dye, over the distance traveled by the solvent.
Which one has leaks?
So pretty much you just match it to like what the intention you did.
This is Ashlyn.
Your traditional one.
After the second one, you can stop it and just redo it.
Abby, can you get me some more?
While doing this lab, we made sure that our solvent was below the 1 centimeter mark on our TLC plate and waited at least 10 minutes or until the solvent reached 3 to 4 centimeters. Once I took the TLC plate out of the beaker, I immediately marked with the line, and I'll measure this line to see how far it went up, which is 2.6 centimeters. So then I will record as the denominator in all of the dyes. Then I will go through and see which measure from the middle of the dye down to the bottom, to the 1 centimeter mark, and that will say the distance traveled of the component. 1.7 centimeters. 1.3 centimeters.
I'm going to mark my solvent line as soon as I got out so that I'll know where that was. And that would be 3.6 centimeters.
Yeah.
So I'm going to record that as my denominator for the distance the solvent traveled. And then I'm going to measure from the middle of each dye to the 1 centimeter line to see how far the component traveled. This would be 2.4 centimeters. And lastly, for our unknown, it would also be 1.2.
I'm going to mark at the dye line. So it's right here. And stops at 2.6. So I'm going to put that as my denominator for all of them. Then I am going to measure from the 1 centimeter line to the middle of the dot. It's 2.3. 2.0.